Okay, so this question I think is a good critical thinking question. So assume that we have two events, A and B, and they're mutually exclusive. Assume further that we know the probability of A is 0.3 and the probability of B is 0.4. So what is the probability of A and B? Okay, so the first thing we might do is think that probability of A and B, I've seen that equation before, right? We go back one side and we're like, there it is. Probability of A and B, right? Just multiply them together. But then you might look and think that, well, Kristen gave us a different equation. Oh, that's right. Right, this was for independent events. So which equation do I use, right? Are they independent or dependent? Well, we don't know. Maybe we could figure it out, but all we know right now is that they're mutually exclusive. So I'd like to point this out because it might be tempting to see this equation or this part of equation that you know is, this part that you know is part of an equation, right, and just to start plugging in values. But let's just think about this, right? We know A and B are mutually exclusive. That means that if A happens, B can't, right? If it's raining, that means that it is, you can't say that it is not raining, right? Those are mutually exclusive. It can't be raining and not raining at the same time. So what is the probability of A and B, right? What is the probability that it's raining and it's not raining? That doesn't make sense. That's impossible. That can't happen. So the probability of that should be 0. Right, and that's what the answer is to A, right? What is the probability of A and B? It's 0, right? They're mutually exclusive. They cannot happen together. So again, I like to point that out because you have to think sometimes with these problems. Don't just see something and think, I'm just going to plug in the values into an equation and get my answer. Okay, what is the probability of A given B? Okay, so this is just asking for the conditional probability. We know that. We know the equation for that, right? That's just the probability of A and B, that joint probability, divided by the marginal probability. We're given the marginal probability. We already solved for the joint probability. It ends up being 0. Okay, so we're good with that. Question C, a student in statistics argues that the concepts of mutually exclusive events and independent events are really the same thing, and that if events are mutually exclusive, they must be independent. Do you agree with the statement? Use the information to justify your answer. Okay, so let's think about it, right? Like if events are mutually exclusive, right, they can't happen together, right? They have to be independent. They're not related. So I think sometimes that's the thinking. But we can, like the problem says, use the information from this problem to justify your answer. Well, we know for a fact, because we're told that A and B are mutually exclusive. So let's find out if, right, these events are independent or not. We know how to do that already. So if we look at C, we know how to figure out if events are independent or not by looking to see that if the probability of A given B, if that equals the probability of A, we know, yes, they are independent. If not, right, then we know that's not the case. So let's plug these in. Probability of A given B, we already solved this in section B, it's 0. Probability of A is given to us, it's 0.3. So these are not equal. If they are equal, we know they are independent. So from this, we realize that because they're not equal, they are not independent. So what this is telling us is that even though these events are mutually exclusive, they are also not independent. So therefore, they can't be the same thing. It's telling us that if something's mutually exclusive, right, it doesn't have to be independent. Right, so I think this is important for pointing out that mutually exclusive and independent events, right, they're not the same thing, and if something is mutually exclusive, something doesn't have to be independent. So I think that's really important to kind of point out, and you see this in this problem. So I hope that makes sense. If not, go back, reread part of the chapter, watch the video again. If you're still struggling, send me a message. We can do another video. We can do another problem to make sure we understand these concepts.